Good afternoon and welcome to our BYK-Gardner September office hours. My name is Sherry Brown, and today we will be talking about gloss theory and applications, one of the first topics that I learned about when I came to BYK-Gardner. Our speaker today will be Noah, and we'll let him do the speaking because he certainly knows more about this topic than I do. Our office hours format is a shortened presentation followed by questions and comments and an open discussion. So please feel free to put any of your questions in the chat box. We are recording this presentation and you will receive the recording right after the presentation is complete. So this is entirely your session. We're open for questions, ready to answer. And with that, I'm going to turn it over to Noah to start his presentation. Thank you.
All right, thank you, Sherry, for the introduction. So to start off, talk about specular gloss reflection. So essentially, if we have a light source, in this example, we have the sun as our incident light, and it shines down over an object. It'll hit that object. You can see all the colors in the rainbow hitting that object here. And what happens is those colors are absorbed into the surface of the sample here. And then what is reflected out is, in this case, it's blue, and that's what we're going to see as the color. So all the colors of the rainbow are absorbed into this sample, and then it reflects out the color that we see. And then after we have that, so that color that we see, we call it a diffused reflection. That's what these lines here represent. And then whatever is left over from that initial incident light hitting the object is shined back as white light. That's usually shined back at the opposite direction of where the original light came from. And that's called our specular reflection, or our gloss. That's where gloss comes from. So we kind of want to look at how is gloss perceived. So gloss is perceived by having an illuminant. So just like the last example, we have an illuminant that hits an object at a specified angle, and then that angle at the opposite end is hit by our observer. So our light comes down, hits a sample, gets reflected back into an observer. And for a glossy surface, what that observer is going to see is they're going to see a very clear outline of what that light source is. Whereas in a matte surface, you're going to see more of a fuzzy, blurry image of what that light source is. And this is because when it hits that surface on a matte surface, there's all these microtextures on top of that surface that's going to scatter that light. And that's what you can kind of see in this diagram here, is all the light being scattered in different directions, but a majority is still making it back to the observer. So this is our difference between our gloss and our matte surfaces. So when we look at the design of a gloss meter, essentially we're following that same geometry that we looked at before. We have an illuminant, and then we have a sensor or an observer. And in this case, inside of a gloss meter, we have specified angles of where this illuminant is coming from and what the apertures are. So we have specified aperture sizes for the light source, and we have specified aperture sizes for the observer. This is documented in international standards. So on top of this, I talked a little bit about the angles of illumination. So in the standards for international gloss measurement, we have 20 degrees, 60 degrees, and 85 degrees. And each of these light sources has a corresponding sensor that is at the same opposite angle as the illuminant. So what these angles are for is essentially, we see this graph here. It's broken up into several different categories. At the top, we see we have low gloss, we have a semi-gloss, and we have a high gloss. And across the bottom on the x-axis is essentially 1 through 13 of gloss tiles that are step-ups from one another. So we say 1 is a step up from 2, and each one of these step-ups has an equal distance from each other visually. So they look visually different. And when we see here is in the low gloss region, we're using an 85-degree gloss meter, and we see that it's a constant value change that goes up in this low gloss region. Whereas when we look at a 60-degree angle or even the 20-degree angle, it's not really constant. The values don't really make any sense. So this is how we're able to determine that the 85-degree angle is best used on these low gloss surfaces. And that's how you get the most accurate gloss value for these low gloss surfaces. Now, when we look at semi-gloss, we see in the middle here that the 60-degree gloss angle, it makes the most sense here. It stays at a constant rate, whereas you look at the 20-degree and it's kind of curving up a little bit, but it's not really giving us accurate representations. And then we look at the 85-degree angle, and it's almost the same thing. It's a little better than the 20-degree, but it's not as accurate as the 60-degree. And then finally, in the high gloss region, we see that the 20-degree gloss meter is working best here, has the most constant value increases. And you see the 60 and 85-degree gloss, it's not as constant, not as accurate. So this is how we're able to determine that which angle is best for certain situations or certain level of glosses. So here we have recommended geometry. So when we look at semi-gloss, it's usually between 10 to 70 units. That's our range for a semi-gloss. And in that range, we'd like to use a 60-degree gloss meter to get those most accurate results when measuring gloss. As for high gloss, we want to use, it's usually less than 70 units, or greater than 70 units. So it's a high gloss. And for that, we're going to use a 20-degree geometry. That'll give us our most accurate measurements for those high gloss surfaces. And as for glow gloss, usually matte surfaces, they're going to be defined as less than 10 gloss units. And for that, we want to use an 85-degree gloss meter. So gloss value is dependent on the refractive index of material. So what this means is that when the first gloss meter was being created, you had a black glass standard, and this black glass standard had a refractive index of 1.567. And what that means is the refractive index is another word for saying how much light is absorbed by that sample. So this black glass standard that was used to make this gloss meter had this specific refractive index, and therefore that specific refractive index was used to state that this is 100 gloss units. So this is how this is where 100 gloss units came from. This is how it was decided. And if you see here, different refractive indexes can give you different measurement values, and it also corresponds with the angles too. So we see here our original refractive index on that glass standard, that polished glass standard, was 1.567, and our 20-degree gloss is 100, our 60-degree gloss is 100, and our 85-degree gloss is 100. This is the only area where it all lines up together perfectly. So that's our standard for 100 gloss units. Now what happens is you have certain situations, I'll show you this slide here, where non-metals, plastic, and paint, they are usually 0 to 100 gloss units. This is because they have either the same refractive index or a lower refractive index. So the light's going to be absorbed more, and you're not going to have high reflectivity. Whereas in metals, like aluminum, you can see that our gloss range goes from 0 to 2,000 on the 20-degree, or on the 60-degree, we have 0 to 1,000. And so we see that it goes above 100. You may ask, why is that? That is because metals, like aluminum or polished metals, they don't absorb that light. So it's going to give us a lot of reflectance back. Whereas in plastic and paints and non-metals, it's going to absorb some of that light. So we're only going to get our maximum is 100 gloss units. And this is a nice example that kind of shows this is we have two different clear coats, high gloss clear coats. And we see one is sitting around a 1.5 refractive index, whereas the other one is sitting around a 1.53. And visually, we see that they're the same. They have the same amount of gloss visually. However, the values that we get are completely different because of how much light is being reflected out and how much is being absorbed. So this can create a difference. And so that's why it's always important to, if you're going to be measuring multiple different substrates or different surfaces like plastics and metals, it's good to have multiple geometries. So you want to have 20, 60, and 85 all in one. That way you can look through the data and find out, if you're measuring something with a high gloss versus a lower gloss, you can get the best and most accurate measurements. And so we have the micro tri-gloss, which measures on all surfaces. You can choose different geometries for it. You can use single, 2, or 3, depending on what standard you're following. It's compliance with all international standards, measures from matte to mirror-like surfaces, and we have this expanded measurement range from 0 to 2,000 units for those metal surfaces that you would measure. So it can measure with just the plastic and non-metals, or it can measure with the metals. And here we have another example of that difference there with why we want to measure with multiple angles. So we see this is a weathering study, and we have panel A measured at 60 degrees, panel B measured at 60 degrees. Then down below we have panel A at 20 degrees and panel B at 20 degrees. So we see here, if we're measuring just at 60 degrees, and this is over a course of time from start to 250 hours of weathering, we see that there's really a small to almost no difference between these panels measured with 60 degrees. We also see that it's in this higher range. So really, we should be measuring with the 20 degree because of this higher range. And when we see what happens when we measure with the 20 degrees, we see this big difference between the two panels, and as well as the weathering over time. So it's important to know which geometry to use. And if you have something that can measure all geometries, that's the best because it can tell the entire story of that sample. And then just to go over, another variable is curvature. So specular gloss is essentially a light shining over an object and getting reflected back into a sensor. And for that to happen properly, you want to have a flat sample. And this makes it so that light doesn't scatter like in this image on the right here, where light comes in on this curved sample. But because it's curved, all of that light isn't going to go back towards the sensor. It's going to get scattered in different directions. That's going to give you a lower gloss value, and it's going to skew your results. So they're not going to be as accurate. So it's important to make sure that your gloss meter is both flat, stable, and the sample is flat. Now, if you have curved samples, there are ways to go around this. For example, using a smaller aperture gloss meter. And what that does is, instead of having a larger space that has to be flat, it's just a small hole where the light shines through and gets reflected back. And you can make a custom jig. A lot of customers make custom jigs to put their gloss meters on. And this helps keep it stable, so you're always measuring the same way every time. And lastly, I kind of want to go over measuring transparent samples with the gloss meter. It introduces a new issue that we have to think about is it not only is going to measure the surface of that transparent material, but it's also going to measure what's underneath of it, so whatever that substrate is. And what plays a role in that is sample thickness. So something to keep in mind is that if you're ever comparing transparent samples by their gloss. You want to compare the samples that have the same thickness, because as the thickness changes, we see that this light gets absorbed into this, or it passes through this transparent material and then gets bounced around, um, and you lose some of that light source. And depending on the sample too, it also might reflect the light source in other directions, and this is all going to miss the sensor. So it's not going to give you the most accurate result. However, if you're comparing transparent samples together, um, you can compare them, but you have to make sure that they're the same thickness, because different thicknesses will result in um, different results, different measurement results. So it's all something to take into account when measuring these different types of samples. Now, it's also important that when you're measuring these transparent samples, you want to usually use something that almost has no reflectance. That way it's not skewing your results and measuring the substrate. So it's recommended to use something with zero gloss units, so like a matte black substrate. So usually like a black felt, because it doesn't reflect light. All right, and that is it.
Thank you, Noah. Thank you very much. That was lots of good information there, and it seems like there's a lot of variables that come into play. If anybody has any questions, you can certainly put those in the chat at this time. I guess just to reiterate, you just happened to mention that if you're measuring samples that are clear or transparent, you had mentioned using a vacuum, and that should be matte black.
Right. And the reason because is you don't want to have whatever that substrate is skewing results, or adding more reflectance than what is actually there. And so you want to use something that has zero gloss units, so zero reflectivity, and that's usually like a matte black surface, or some people use a black felt because it's not reflective.
And in this presentation, you went over 20, 60, and 85 degrees. Is there other degrees of gloss that we sometimes use for measurement? Are you able to tell them?
Yes, so there are other variations. 45 is one of the other variations, and these are used mainly for certain industries that have certain standards. So they're not widely used around. That's why they're not depicted in this presentation here, but they do exist for certain industries.
We do have a question that sort of goes back to the transparency that we were talking about. How thick does the sample need to be if it's transparent to make a significant difference in the gloss?
So really, if it's any type of transparent sample, it's going to make a difference when you're measuring with a gloss meter. The difference is if you're measuring samples that have varying thicknesses, is you won't be able to accurately compare them together, because that light's going to go in and get scattered differently depending on the thicknesses. Does that answer your question?
I'm not sure if someone's typing, so we'll see if that answered it. And if not, maybe we can open it up to, or we can reach back out to them then again. We have another question. What do visual gloss values mean?
So I believe you're referring to this slide here. I mentioned visual gloss, and what that was is just saying visually, when looking at them, at these two samples in this example here, they both look exactly the same. You won't be able to tell a difference. There's really no such thing as like a visual gloss value. because you can't assign a value to what you see because everybody sees things differently. But essentially what I was trying to explain was the difference in these samples is the refractive index, so how much light is absorbed by each of these materials. So one of them absorbs light differently than the other, and when you measure them with the gloss meter, because they're absorbing lights differently, they're not reflecting the same, they're going to read differently. However, they look visually the same, but they're different materials. So it's an issue. It's something you want to think about if you're comparing results with, a metal versus a plastic substrate.
And also an instrument give you an objective reading versus looking at something and thinking it looks fine because you can't see a difference with your eye. Is that correct?
Right.
So someone has also asked what the difference is between a gloss meter and a wave scan.
Okay. So they're two different instruments that measure very differently from each other. A wave scan is designed to measure the waviness of a surface, whereas a gloss meter is just measuring the gloss of a surface. So it's measuring that specular reflectance that's coming off of that surface. So it's two very different things that you're measuring.
Does that answer? Yes, he said thank you. So that answered the question. Yeah. Are there any other questions today or anything that anybody's thinking about? I know you had mentioned that we can measure curved surfaces. We just have to maybe have a special device or a smaller aperture to be able to measure on that curved surface, but it's best if the gloss meter can remain flat.
Right. So depending on how curved that surface is, like say for an example, it's just a slight curve. What you could do is you could create a jig that the gloss meter would sit on, and it would make that the port is only going to be flat all the time, essentially. So if you were to put a flat bottom gloss meter on a curved sample as is, it's possible to move it around, and you don't want that. You want to be able to measure consistently the same spot on different samples. So you want to have some type of device or holder that holds it completely still and flat every time. Now you could also, what a lot of people do is they have different smaller aperture gloss meters. So something that's 2 millimeters by 4 millimeters. And what this does is it makes it easier to read over these curved surfaces because you're not having this large sample aperture, whereas you have in a regular gloss meter that's around 15 millimeters by 10 millimeters wide.
Would you recommend a smaller aperture when measuring something with small effect and glitters?
For that, I would recommend a regular gloss meter or even a BYK-Mac if you want to really get a good representation of what those effects and glitters have in them. But no, for that, you would want more of something that takes a larger sample area because you want to be able to measure what the actual sample looks like rather than just a small section of that.
Megan, I'm glad we were able to answer your question. And if you have any other further concerns about that, we can certainly talk with you one-on-one about that. And not that we're going to get into a colorful conversation today, but we do have some instruments that measure both color and gloss, because sometimes you want to be able to really see what your eye is seeing with the effects of gloss or without the effects of gloss. So I think that's a benefit to some of the instruments that we sell as well. Does anybody else have any other questions today? Not seeing any coming in right at the moment. Noma, do you have anything that you wanted to recap or anything before we give everybody back a little bit of their time today?
Yeah, if I could recap one more thing, I would have to say, I'll go over this again, but essentially, when you have these different refractive indexes or different materials absorb light differently, so if you have metals and non-metals, it's also important to look at the reflectance, which is it's essentially the same thing as gloss units, but it's a little different. Reflectance is usually measured instead of gloss units on metals, and essentially they're interchangeable. So you can use a calculation to go from gloss units to reflectance. So, for example, if you're measuring at 60 degrees on a metal surface, and you have 500 gloss units, you would just take 1,000 divided by 500, and that would give you 50%. So you can really change them out with each other. But it's just something to note because in some industries, people measure with reflectance or gloss units, and it's good to know that they're interchangeable.
Thank you. Well, with that said, if anybody has any other questions, please type them now. We do office hours normally, once a month, and then we also have other webinars that we do, which are longer. It's more of a 40 to 45 minute presentation that goes more in depth. Time for question and answers. On any of the emails that we send out, you can always go to them, ask any questions that you may have, in touch with the person to help you. This is recorded and we will send the link out. We also have a YouTube page that all the recordings are there, and there's lots of valuable information if you ever wanted to go there and re-review, re-listen to any of the webinars that we've done. And if anybody has any ideas on a webinar that they think that we should, offer, please feel free to send any of those ideas to us as well, and we will incorporate those into our program. I think with that, I don't see another. So I think maybe we'll go stop the presentation for now. I believe that some people are taking some boxes up in the background. So sorry about that. I hope everybody has a great day. And like I said, feel free to reach out to us if you have any additional questions. Thank you.